Assalamu alaikum, Bismillahirrahmanirrahim. Today, we discuss about ISIS. It's a routing protocol. It's an IGP, Interior Gateway Protocol. Okay, and so first we have to complete theoretical part first, and then go to lab section after finishing our theoretical part or theoretical concept. Okay, so let's start. Size intermediate system to intermediate system. So it's a interrogated protocol. It's used as a ICP, and if you compare it with OSPF, it's basically similar to OSPF, and they um, choose best path based on Dijkstra algorithm, based on Dijkstra algorithm, and it's make trigger update like OSPF. So it's also a link state routing protocol, and depends on link information. It takes the routing decision. So basically, this protocol is developed by ISO. Basically, this was a connection-less network protocol. After that, this protocol moderate in recent era. It's basically ISIS, intermediate system to intermediate system, and it's added multiple TLP to modify or optimize multiple parameters, routing parameters, basically. So we say this ISS means dual IS or dual ISS. You can say like this. We normally say it's ISS routing protocol. Okay. So, what is the feature of ISS? Number one, it's a link state routing protocol. Number two is it's an ICP. Like OSPF, it's have a trigger update feature. Okay. And more interesting thing is OSPF have two type or two say two variations or two version. You can say two version. OSPF version 2 for IPv4 and OSPF version 3 for IPv6. But in ISIS, there is no version. ISIS basically a single version, and single version can speak for IPv4 and IPv6 both. Okay, so there is less configuration in ISS, but if you see the configuration, it's a little bit complex compared with OSPF. Okay. So you I already I already say it's an IGP, so it will be under one single autonomous system. You know what is the autonomous system, and and there will be multiple terminology. One terminology is AND system, and another one is intermediate system. AND system is network entities or hosts that send and receive packets. That is called the AND system. And intermediate system, network entity, that means routers that send and receive packets and relay for packets. And ISS packets, basically it's a PDU, protocol data unit. Basically, we use PDU, this term, in layer 2 frame, but in ISS, ISS packet is called basically PDU. Because this can communicate without IPv4 or IPv6. They are just communicating based on layer 2. Okay, in that case, the packet is or packet type is PDU, protocol data unit. Okay. Likewise, WSPF have a multi-area concept. You can divide your topology in multiple area, and single area you can choose multiple router. Normally, we consider around 50 router will be okay for one area. So if you have more than 50, you can divide your topology in multiple section or multiple area. Like OSPF, you can divide your topology when you configure or when you plan to deploy ISS in your topology or in your network. Okay, so consider here there is multiple area 1, area 2, area 3, area 4. Okay, so in OSPF, all areas should be connected with backbone area. That means area 0. But there is no restriction in ISIS. Any area can be connected with any area. There is no restriction. Okay, there is no application. Okay, then there have two concept. Level 1, L1 means level 1, L2 means level 2. Okay, in a area there is two name, level 1 and level 2. Level 1 means route within an area and towards the level 2 system. That means when you configure the router, by default one single router will act as a level 1 level 2 router. That means they will act as like both level 1 and level 2. But consider here, if you consider by default action or by default nature, see here, this is level 1 level 2 router, this one is level 1 level 2 router. So it will work as a level 1 level 2 router when communicating one router, like say here, level 1 level 2 router is communicating with level 2, level 1 level 2 router is communicating with level 1. Okay, so there is some rules in ISIS. There is some rules in ISIS when you plan to deploy, or when you define your router as a level 1 level 2 or level 2 router. Okay, so there is some rules. Okay, so if you configure a router as a level 2 can communicate with level 1 level 2. But when level 1 and level 2 router, like consider here, this router is level 2 router and this router is level 1 router, they will not make any adjacency. So there is some rules or constraint. So I'll show you the detailed constraint in next session or next chapter. Okay, so ISIS and OSPF, this is the comparison, and and this is basically the concept of ISIS areas. In ISIS areas, level 1 and level 2 router fulfills the same purpose as an area border router. So level 1, level 2 router, you can compare with OSPF area border router. Okay. The collection of level 2 routers in ISS is the backbone. That means if you consider some area is backbone area, so in backbone area, all router will be level 2 router. All router will be level 2 router. You can compare with OSPF, those are area 0. Okay. So this is the comparison between ISS and OSPF. Maintain linked state database and construct a shortest path tree. Both are using Dijkstra algorithm. Okay, both are using Dijkstra algorithm to calculate the shortest path. Use hello packets to form maintain adjacency. For maintain adjacency or neighborship, they use hello packets. Use two-level hierarchy. Provide for address summarization between areas. Both have this one. Elect a designated router. Have authentication capabilities. Both have authentication capabilities. So um, mm, you can say WSPAP and ISS is very much similar, but some have little difference. Okay. ISS PDU, protocol data units. So types of ISIS PDU, protocol data unit. So in OSPF, we are saying packet, and the and, routing message is called the packet, but in ISIS, we say it's a PDU. Okay, hello PDU, link state PDU, sequence number PDU that can be complete, that can be partial, and last one is TLP, type, length, and value. There's a multiple type ISS packets or ISS PDU. When you making a neighborship, when you configure two routers to make ISS neighbor, then this message type will be communicate between this router. Okay. IIS. IIS means this is I says hello. First I means IS, that means IS. Second I means IS. And last one is ACE, that means hello. That means I says hello. I says a hello message. So in ISS hello message, a hello mechanism for neighbor discovery used to build and maintain adjacency. Same purpose, similar to the hello mechanism in OSPF. In OSPF, they are using hello packet to check neighbor is exist or not, neighbor is live or not. Okay. Separate hellos for broadcast networks. Well-known multicast address used for level 1 and level 2 hellos are this one. For point-to-point networks, I they are use separate hellos. That means if network type is broadcast, the hello type is different, and if your network type is point-to-point, the hello type is different. ISS transmit IIASPDU at regular intervals, like OSPF. Okay, there is no difference. So ISIS hello PDU, uh, they should contain identity of the device, describe its capabilities and parameters of the interface, like interface IP address, subnet, or others information. So this is the ISIS hello PDU total field number, and this is the function or description of the fields. Okay, the circuit type, that means your router is act as a level 1 router, level 2 router, or both. Okay, this PDU field is called the circuit type. Source ID identifies the system ID of the router that originated the hello PDU. That means which router sending packet, that will be the source ID. Okay, a holding time or hold time, PDU length, priority. Basically, priority is used for DI selection, which will be the designated or which will be the backup designated, like OSPF. And last one is LAN ID. So LAN ID is basically used for DI's election. Okay. ISIS link is state PDU. You can say if you compared this one with OSPF, link state update, link state request, Okay, same like this. ISIS link state PDU. Link state PDU protocol data unit are used to build the linked state database. Oh, what is the meaning of linked state database? Linked state database meaning it's a route, ISS route that is called linked state database. Similar to linked state advertisement in OSPF. So a separate linked state video like for level 1 system, for level 2 system, there will be separate linked state video are sent as a result of network change during adjacency formation and in response to sequence number video. So when sending the ISS link state video to neighbor router, they are sending those information to neighbor and neighbor also sharing similar information. Okay. ISS sequence number PDU. This sequence number PDU is used for just for uh, mm, making synchronization linked state database. If any any if any linked state PDU missing, then you can recover those one. Okay. In that case, ISS sequence number PDU is used. Okay. Okay, sequence number video, similar thing. Last one is TLP, type, length, and value. This is basically modular section in ISS. If you need any additional feature, like if you segment routing is now coming. So when you enable the segment routing in ISIS, so and that will be just added new TLP, and those feature is in-house or embedded in ISIS routing protocol. Okay, so this is called the TLP, or you can compare the BGP address family. You just introduce a new address family and the BGP capabilities is increased and they are working with new address family like this. TLP is like this. Okay. Some common TLP used for TLP code, and this is the TLP code and defined basically ISO and RFC. TLP code one, this the that is for area address. So there is multiple TLP value, and those are used for multiple purposes. Okay. So next, forming adjacency. When forming adjacency, that means forming neighbor between two routers. There is some rules. Okay. So ISS adjacency rules. So what is the rule? Number one rule is level 1 routers never form an adjacency with level 2 router. That means you configure two router. Consider here this one is level 1 router, and consider here this one is level 2 router. If you configure ISIS between this router, your adjacency or neighbor will not form. Okay. So this is the number one rule. Reverse is also true. That means this router is level 2 and this router is level 1. This will not make adjacency. Okay. Number 2, for level 1 adjacency, area ID must be the same. If you want to make adjacency between level 1 router and level 1 router, those router should be in a area. Consider this is area 001. This router is level 1 router. This router is level 1 router. So this is possible to make adjacency. For level 2 adjacency, area ID can be different. For level 2, this is the level 2 router and this router is the level 1 level 2 router. So this router will act as both level 1 and level 2. So in that case, In that case, when making adjacency between these two router, they are communicating as a level 2. This router act as a level 2 and neighbor is level 2. So adjacency will make. So consider this router is level 1 and level 2. So consider here it's the same area, same area. So here if we consider level 1 communication between this router, adjacency will make. Same thing will be happened here. Same thing will be happened here. Okay. So if you consider this router will act as only level 2 router. This router will act as only level 2 router. So say here only this adjacency will make. This adjacency not possible. Level 1, level 2 not possible. This adjacency not possible. Okay. So when you configure or when you want to deploy ISS configuration in your topology or in your network, first you have to consider these three rules. Number one, two, and three. You have to consider three rules. Very important. Okay. DIS. So ISI selects a DIS on broadcast and multi-access networks like OSPF. In OSPF, the name is designated router or backup designated router, but in ISIS, the name is DIS, designated IS. So in case of priority tie, the system with the highest subnet point of the attachment or MAC address wins the DIS selection. So here for DI selection, priority is the major factor. If priority is tie or priority is same, then next choose the highest subnet point or MAC address for DI selection. Okay, DI's characteristics like OSPF, ISS matrix. Like OSPF already use the matrix to calculate the shortest path. Like OSPF, ISS also use the matrix. But here the matrix is two type. You can say this the default matrix and another one is white matrix. Okay. So matrix, what is the activities of matrix? So what is the function? Matrix is used for calculating the shortest path in ISS routing protocol. Okay, so see here, ISS interprets a single record and default matrix with a maximum path value of 1023 as the cost. Arbitrary and assigned by network administrator. Any single link can have a maximum value of 63. That means metric value you can assign. ISIS calculate path links by summing link values. Like WSPF, calculate the total metric value. When you consider one source to another destination, so calculate the total path metric. And if you have multiple path, then they calculate which one is the shortest or which one is the lowest metric. Lowest metric value will be the primary path. It's a similar concept in OSPF. Okay. So ISS matrix this is another option. This is called the white matrix. So white matrix are always sent. Their value is limited to 63 unless you disable standard matrix with the label white matrix only. So maximum value for any one link is 2 power 24. That means 16 billion. You can say it. For white matrix, the benefit is you can choose your matrix value as you choose. Okay, that is the difference. Configuring ISS. First one is s- just go to protocol ISS, include the connected interface and include connected interface and mention which level will activate for that interface. Okay, like consider here for this interface level 1 disabled. That means for this interface router will work with level 2. Here level 2 disabled. That means for this interface when communicating with another neighbor, they will communicate as a level 1 router, as a level 1 router. So here level 1 is disabled, level 2 is disabled, level 2 is disabled. So you can say this router act like a level 1 level router. That means both. Okay. And another step is you have to include ISO family. Which one is included in ISS routing protocol? Okay, ISO family. When you set IPv4 address, you set the family is INET. When you include this interface will participate in ISIS, you have to add the ISO family. Okay, this is the second step. Loopback 0 ISO family. Okay, third step is you have to define a net address. You have to define a net address. Network entity title. Network entity title. Normally, we make this net address from this loopback interface. 49, this value is fixed. 0001, this is area ID. And this number is the system ID. Okay, this number is the system ID. Basically, this number is coming from this loopback address. This address should be unique for one router, like WSPF router ID. Okay, so see, consider here IPv4 is 32-bit. If I consider 0, 0192, consider here 0, 0168, 0168. Here is 2. That means you can say 0, 2, 0, 1, 0, 2, and 0, 1. You can write like this, or you can say 192.168.002.001. So you should take 4. So this is first one, 6800. This is second one, and 2001. This is fourth one. You can think like this, no issue. Okay, but address, net address should be unique. That is the main constant. So how to check ISIS neighborship? Just show ISIS interface. This interface will show you the details of ISS. Is it working as a level 1, level 2? What is the metric value? Is it working as a point-to-point, or it's working as a broadcast or non-broadcast multi-access? Circuit ID, everything. Show ISS database like WSPF. This also is stored the database. ISS adjacency, just checking the neighborship. Your neighborship is up or down. See the state. If your state is up, that means your ISS is operational. ISS adjacency detail. In detail section, you will get multiple options, and the state is a ISS adjacency. You can clear single or all ISS adjacency. Just set the command clear, like OSPF, clear OSPF. You can clear all OSPF domain, or if you want to clear single adjacency or single neighbor, just press the command clear OSPF, then neighbor. In ISS, similar, clear ISS adjacency and then mention the neighbor name. Show ISS SPF log, shortest path log, and this is the statistics, and this as statistics basically show you which PDU type is communicating with each other. Is this LSP, CR, IIS, CNSP, PNSP, unknown, and the total. Show ISS route. If your ISS is up, you will get ISS route in your route table. So what is the verification command? Show ISS route. You can place like this, or show route protocol ISS. You can place like this. Show ISS database extensive for detail. If you want to debugging ISS protocols, you can set trace options. You can set trace options under protocol ISS. So what is the troubleshooting step? This basically this is the basic ISS troubleshooting step. First one is ISS adjacency do not require or rely on IP configuration. Okay, it's communicating based on L2, based on layer 2. That's why it's don't rely on IP configuration. Okay, but in OSPF, you have to configure IP address. Otherwise, OSPF will not make adjacency. Okay. If no adjacency, check for the following problems. You configure ISS, but your neighborship will not up. You just configure ISS, but your neighborship yet not coming up. So that can be multiple reason here. So number one is physical layer or data link layer connectivity. Maybe your link is down, or maybe they are communicating based on layer 2, but in layer 2 maybe they are not communicating. It may be MAC issue, or it may be VLAN issue. Okay, mismatch areas. If a label on router and labels, if you misconfigure label, or if you misconfigure areas, that can be a reason to not up. Failure to support minimum MTU 1492. This is the minimum MTU. If you configure interface MTU less than this, ISS will not up. Lack of or malformed, that means ISONet. If you configured ISONet is the wrong address, or if you duplicate this address, so your neighborship will not up. Okay, so this is the multiple reason when you configure ISS in your production, you have to consider this one, this troubleshooting step. Okay, this is the lab section. So go to our lab section and check ISS configuration. Check ISS configuration. So today we can take very simple topology here. Very simple. Okay. Only 4 router and area is 2 area 1 and area 2, and number of router is 4. Consider this topology and create our lab. So take first BMX, number of node is 4. Okay. Ethernet interface 8. Router is BMX. Save. There is 4 router. Okay. BMX1, you can see this is different area. Different area. This router is in area. This router are in area. That means like this. Okay. Just connecting 0, 0, 7. Mm. Okay. That's okay. First, consider. Okay, start. First, consider IP address here, like 10.20 dot 1.1/32. This is hello 0 loopback address. So 10.20.11. This is router 1. Duplicate. For router 2, loopback is 2. For router 3, loopback is 3. For router 4, loopback is 4. Okay, simple 4. Now consider here point to point. The point to point IP address is point to point will be /30. So consider here 4 4.0/30/30. So consider this one 4.0, then 2 to 3 or 1 to 3, 4.8, duplicate. This is 4.12, another /30, and the last one is order 16. So that's okay. And this is, say here, area 49002. So these are duplicate. Area will be area 49.0.0.0.2. This router 4 is area 49002, and router 1, 2, 3, this router area will be 1,001. Okay, so first go to router 1, go with router 1, appearance 12, that's okay. Route 1, 2, 3, router 2, router 3, and finally router 4. Then it display set. This device have some default configuration. Need to remove this one. Route 1, 2, 3. CLI, edit. Router 3, route 1, 2, 3. CLI, edit. Router 4, route 1, 2, 3. CLI, edit. So press this command, show pipeline display set. All router have default configuration. So need to remove router 2 management interface, and this is VMX1, VMX, all router is VMX1. So need to modify the router name VMX1. This is VMX1. This is 2. This is 3. And last one is 4. Best default configuration. Remove. Remove. Router 2. Logical router 2. Remove. And the management interface. No need this one. Okay. So okay, just a minute. So first we configure the basic configuration of 4 routers. First, I'm in router 1. Router 1 set loopback interface address, set interface hello 0 unit 0 family inet address. My router 1 address, loopback address is 10.20.1.1/32, and interface, there is two interface, 0 and 2, GE dash 0 by 0, 0 by 0, unit 0, family inet address is 10.20.4.1/30. Another interface is interface 2. Another interface 2. IP address is 4.8. In router 1 side, I configure here 4.9. So our address configuration done. Show display set. So first one is loopback, router 2, loopback is 2, router 3, loopback is 3, router 4, loopback is 4. Done. Then interface 0, router to 0 interface IP address will be 4.2, and one interface IP 001, one interface IP will be 4.12, that means 13. Submit. Show display set. Router 3. Router 3, one interface IP is 14, and two interface IP is 10. Router 3, two interface IP is 10, 4.10. So show display set. 3 to 4. 3 to 4 interface is 0. Router 3 interface 0. IP address is 4.16. That means 4.17. Comment. Router 4 18. 4.18. So that's okay. Our IP configuration has done and 4 routers. Now move to ISS protocol. Okay, so edit protocol ISS. Then you have to add connected interface. You have to add connected interface. So see the configuration example here. First one, you have to add connected all interfaces. Okay, so first one, in router 1 there is 3 interface, loopback 0, 0 and 2. So set interface, see here, loopback is, sorry, hello 0, loopback interface. I'm not mentioning level 1 or level 2, just enable ISS protocol. Okay, simple. Interface 0 and another interface is 2. So 3 interface is connected. I'm adding here 3 interface simply. Okay, so display set top commit. Router 1. In router 2, 0, 1. In router 2, your interface will be 0, 1. That means this interface is 1, and finally loopback 0. Commit. Router 3, there is 4 interface here. 0, loopback 0, 0, 2, 1. 0, 1, 2. That means in router 3, all will be here, and another interface will be 0, 1, 1, 0, 1, 2. Commit. Router 4, interface 0, and interface loopback. This 2. So step 1 done. Move to step 2, ISO family. So introduce ISO family on respective interface. Okay. So you can filter RSS configuration from all router configuration like this. Okay. Configuration like this. So show display set. This is the all configuration. Router 2, router 3, and 4. So we need to enable ISO family. We need to enable ISO family. So just family ISO. There is multiple family ISO, that means OSI ISO protocol parameter, that means ISIS parameter. So 0 interface 2 family should be ISO, and interface loopback 0 family should be ISO. So if you mass ISO family is for ISIS routing protocol. Okay, like inet for IPv4, inet 6 for IPv6, ISO for ISIS routing protocol. Then go to router 2. Router 2 connected interface loopback, interface 0, interface 1, interface 0, interface 1. So copy this one, 0, router 2. This interface will be 1, and finally loopback 0. Commit. So this is the second step. In router 3, this interface, all interface 0 to loopback 0, 0 to loopback 0, another interface will be 1. So adding interface 1. Commit. Router 4, 0 interface and loopback interface. So this is the second step. You enable ISO family which interface is will be connected in ISS routing protocol. Okay. Then last step is family ISO address. You have to set family ISO address, that means INET address, network entity title, that should be unique. So how to make this one? First try to for router 1 ISO address. ISO address, first one is you have to write 49. This is the unique number for net address. Then area ID, then system ID. So my router one loopback address is 10.21.1. If I consider like this, um, 0, 1, 0 and 0, 2, 0, 0, 0, 1 and finally 0, 0, 1. Considering 3 digit, every octet considering 3 digit. So when we make system ID, need to take 4 digit in a field. First one, and this is second one, and this is last one. You can think like this. Okay. So first 0, 1, 0, 0, 1, 0, 2, then dot 4 digit after dot. Okay. 0, 1, 0, 2, that means after 2, 0 and 0, 0, 1 dot, this one covered, and first one is 0, 1, this is 1, 0, right? 1, 0, before is 0, this is first one, here number will be 0 and 2 will be here. First one is 0, 1, 0, consider 10 is 0, 1, 0, 20 is 0, 2, 0, 0, 2, 0. Okay, 1 is 0, 0, 1. That means more 0 will be here and 1 will be omit from here. Finally, here is 1 and last one is 0, 0, 1. So this is the system ID. This is the system ID. Finally, last bit will be 0 every time. Last 2 digit will be 0. So this is the process to make net address. So shall best plus set. This is the net address for router 1. For router 2, last one will be changed 1.2. Okay, 1.2. That means this will be 2. Everything will be same. 0, 0, 2. Done. For router 3, this is 0, 0, 3. for router 4004. So my net address configuration done. Okay, then check ISS details. Run show ISS. This is the detail command. We show here ISS interface, ISS database, adjacency, adjacency detail. Okay, every verification command is here. First, we need to verify the adjacency. Okay, say here run show ISS adjacency. Router 1, there is 4 adjacency. But if you log into voice web, for voice web, this adjacency number will be 2. Router 1 is directly connected with 2 routers. In that case, neighbor will be 2. But in ISIS, neighbor is 4. Adjacency is 4. Okay. Say here, first one, this is the duplicate, interface 0. Second one, this is the duplicate, interface is 2. Here is also the duplicate VMX2, another is VMX3. Label, level 1, level 2. Level 1, level 2. State is up, and this is the whole time, and this is the SNP address. So VMX1 make 2 adjacency basically. For level 1, one adjacency for level 1, another adjacency for level 2. That means by default, this BMX1 router act as a level 1 level 2 router. This router act as a level 1 level 2 router. Okay, that's why making duplicate adjacency. That's why making duplicate adjacency level 1, level 2. If you not disable label, so you can see like this duplicate adjacency. So consider here BMX1, BMX2. So I am checking another router. This is also duplicated adjacency. Here is also duplicate adjacency. Here is also duplicate adjacency. So need to optimize this one. Need to optimize this one. So BMX 1 and 2, this router in a area. In that case, you can consider this router work like level 1 router. That is the enough. Okay. Level 1 router. That is enough. Router 2. It's very small. That's why problem. This is level 1. This is level 1 router. Okay. So both are level 1 router and both are in a area. So if both level 1 router and in area, they will make adjacency. No issue. They will make adjacency. No issue. Okay. So you can disable level 2. You can disable level 2 from VMX1 and VMX2. You can use this command. Level 2 disable. Level 2 disable. So if I disable level 2 here, If I disable level 2 here, this router work as a level 1 router. Work as a level 1 router. So edit protocol ISIS show. You can disable like this. Set disable. Set disable level, and the level value is 2. Set disable level 2. If I make this one, set disable level 2. This router connected interface number is 2. One is 0, another one is 2. For both interface, level 2 will be disabled. For both interface, level 2 will be disabled. You can do like this, or you just mention here the interface, then disable, and the label value, level 2. You can work like this. You can work like this. Okay. So this BMX1 working as level 1. So in that case, I choose here first one. Set disable level 2. Set disable level 2. Set disable level 2. Missing argument. Why? Set, oh, set level 2. Then press disable. Okay. Level 2 disable. So this router will work as the level 1 router. So if I check now, level 2 down. See here, level 2 down. Just wait for some time. That means the whole time level 1 will be cleared from here. So like router 1, router 2 also act as the level 1 router. So set protocols, label, set protocols, ISIS, level 2, disable. Comment this one. If I disable level 2 from router 3, if I disable level 2 from router 3, that will work as a level 1 router. This level 1. So level 1 and level 1 in a area adjacency will make. But level 1 and this is considered level 2. This will not work. Level 1, level 2. If I consider this is level 1, level 1, but this router in different area, adjacency will not make. So if you consider router is a ABR, area border router, this router is connected with area 1, also connected with area 2. This router will act as a ABR, area border router. For area border router, you need to choose both level 1, level 2. You need to choose level 1, level 2. For in a area, they are working as a level 1 router. For different area, this router work as a level 2 router. That will make sense and you will get adjacency. Okay, just check 2. No duplicate adjacency here. That is expected. Router 2, there is no duplicate adjacency here. That is expected. Okay. But If you check from here, see here, with router 1, single adjacency, with router 2, single adjacency and level is 1. So for router 1 and router 2, that is optimized. For router 4, there is multiple adjacency. Multiple adjacency. So if I make this router as a level 2, this adjacency will make, but this will goes down. So in that case, BMX3 should work as a level 1, level 2. So which one we should optimize? This one we can optimize. If I configure this as a level 2 router, so this is level 1, level 2. So level 2 in different area, they will make adjacency, no issue. Level 1 in a area, another level 1. Level 1 in a area, another level 1. They will make adjacency, no issue. Okay. Okay. So customize last one. Set protocols ISIS level 1 will be disabled. Okay. So commit this one. So check adjacency. See here, level 1 disable and level 1 goes down. Just wait for whole time. Router 3, there is no duplicate adjacency. Router 3 is connected with 3 different router and their adjacency is 3. Adjacency is 3. Perfect. Clear? Alvarez? Okay. And there is some verification command. I show here now. No, next class will be switching. Switching section will be start. After switching, MPLS will be start. Yes, clear. So now optimal. Okay. So you need you can check run show ISIS multiple verification command here like interface. That means which interface is connecting and another interesting thing is neighbor host name. They discover host name, circuit ID, hmm, layer 3, and this is the label, and this is the metric. Default metric is 10. Default metric is 10. So if I check from router 4, level 1 disable, level 2 is communicating, and this is the metric. And you can check statistics. They are communicating or not. Okay. Then ISIS host name. They are discovering the neighbor device host name. Okay. Neighbor device host name, ISIS host name. I'm in router 4. I'm in router 4. They're discovering BMX 1, 2, 3, dynamically discovering the host name. Okay. And overview. This is the ISS overview. Router ID, adjacency, hold down enable, maximum areas 3, LSP lifetime, SPF delay, and other parameters. IPv4 and basics both are enabled. Traffic engineering by default enable. For level 1, internal and external route preference. For internal, route preference is 15 and external route preference is 160. If level to route, the preference will be 18 and the external route preference will be 165. Okay. And you can say, yeah, you can see here database, database. Okay. And final route. That is interesting. ISO.0. See here, I'm in router 4, getting this route 1021.1/32. This is the destination. This route is coming from router 1 and this route is installed in inet.0 and the symbol is star, that means this route is active. And what is the routing protocol use? ISIS. And see here, the preference is 18. Preference is 18. That means this route is level to route. This route is level to route. Is the timer, is the metric value 10 plus 10. Router 1 to router 3, 10. Router 3 to router 4, 10. That means 10 plus 10 metric value is 20. And this is the next hop, 4.17. And this is the exit interface. So that is the detail of route. Okay, I'm checking this route. I'm checking this route from another area. Router 4 is in area 2. Oh, one thing, this should be area 2, not area 1. This is the mistake. Okay, area 2, not area 1. Okay, delete, commit, show display set. This is the mistake. Yes, configuration corrected and show ISIS adjacency. Yes, my adjacency is up as a level 2. Then check route table. Yes, getting and extensive. See here, this is ISIS. Route preference is 18 and this is a level to route. This is a level to route. Okay. So same thing, place router 3. But in router 3, the preference is 15. See here, the preference is 15. Same route getting through ISIS, the preference is 15. I'm getting this route in router 3 as a level 1. As a level 1. Because router 3, 1 and 2, these 3 router in a area. In a area. In area, VMX1 is a level 1 router. VMX1 is a level 1 router and the connected loopback interface route coming in router 3 as a level 1. as a level 1. When this route is going to another area, this type is converted. Level 1 to level 2. This type is converted level 1 to level 2. Level 1 to level 2. That's why preference different. The In router 4, the preference is 18, but in router 3, the preference is 15. So ISIS level 1 and level 2 preference will be different. In router 2, that will be 15 because router 2 is in area, and router 1, this is connected prefix. Okay, so that's all for ISIS today. Any query or any question regarding ISIS? Nothing, right? Okay.